Hello, my name is Sarah Saunders. Myself and Kevin Rudland, we head up the open source cloud engineering team, which used to be called the Java team, but we've renamed it so we get scope to play with technologies like Alexa. Okay, so the agenda for today, I'm going to talk about how an Alexa skill, which is the application, well, the name for an Amazon application which listens to you and does something via Alexa. I'm going to talk about how we built one in our team. I'm going to talk about why, what it does, how it works. I'll do a demo if I can find a willing volunteer. And then I'll drill down into exactly how this application works and then draw some conclusions about what we learned about developing for voice. So it all began when I went to a talk by a guy from ThoughtWorks whose title was Head of Things. And I thought, I really want to be head of things at Capgemini, so how can I get into the Internet of Things? So I started drawing some Internet of Things cartoons, as you do. And I also went to an Alexa Dev Day, which are free conferences put on by Amazon throughout cities of Europe and the world. And they just show you how to use your Alexa, how to write your own skills. So I went along and sort of picked up the basics. And then we, Capgemini, are platinum sponsors of a conference in London called DevOxx UK. And so I decided that maybe I'll build an Alexa skill for DevOxx. We are platinum sponsors, we were last year and the year before. And the reason that we go to DevOxx is we've been attending for a while, talking and just listening. And we really like the kinds of people that go there. We really like the attitudes, the forward-thinkingness, the technologies that they review. And we wanted presence there in order partly to recruit, because we're constantly looking for good and interesting and interested developers, and also to promote Capgemini as software engineers, because a lot of the time when we meet people they say, oh, I didn't know that Capgemini did software engineering. I thought you were HR transformation or SAP installation or anything. So we wanted to show that, yes, we really do low-level kind of development and software engineering. And so we had a big stall. Our competitors are there too, so there tends to be IBM, Microsoft, Oracle, and Capgemini. And we had to try and differentiate ourselves. And the past couple of years, we kind of focused on a people angle. So IBM have got their scientists in suits, Microsoft have got slick videos, and there was us with our pens. But we wanted to have some demos that would just be talking points. So when people are walking around, they could come over and go, you know, what's that, what are you doing? And also keep to this theme of, you know, it takes all types to make a team. You know, we want everyone to work at software engineering in Capgemini. It's not just, you know, 20-something geeks. We want a wide range of people. So we came up with, maybe thought we could use this, the open extended Jungian type scales to attract people over. So this is an open source equivalent of the Myers-Briggs personality test. So you might have come across the Myers-Briggs test. So this has 32 questions, and they're in the format of, do you prefer A or B? So it might be like, do you prefer to make lists or do you rely on memory? And you need to answer that question in a scale of 1 to 5. And once you've completed the 32 questions, there's an algorithm, again open source, so if you disagree with it, you can submit a change. And it will give you one of these base personality types. So there are 4 pairs that you get given. You can be introverted, extroverted, you can be sensing, intuiting, feeling, thinking, perceiving, or judging. So that gives 16 possible combinations of personality types that this OEJTS quiz will assign to you. So we thought, yeah, we'll bring this along to DevOxx just for fun. You know, we'll make clear it's open source, we're not evaluating you. And in fact, it went down really well. A lot of people were very interested. They'd done the Myers-Briggs test. They liked this kind of thing, so it worked really well. And we thought, wouldn't it be great if we could get Alexa to take them through the quiz? So that was my mission, to build something using Alexa. I'm broken again. Oh, there we are. Okay, so we took the 16 personality types and we roughly grouped them into made-up cliches of software developers. So we had the server-side dev, your front-end dev, we had a DevOps developer, a new technology person, you know, something like the AIE, plays with new technologies, and then the agile coach who looks more at the sort of bigger picture. And we just made up the assignment of how those Myers-Briggs personality types might fit to the characters. And then we got awesome artists to define the characters. So there, obviously on the far left is your front-end dev. Then you've got your server-side dev, your captain of DevOps in the middle, your agile coach, and your excitable new tech. And we came up with the hashtag diverse teams. Moving on. Oh, come on. Right, so what I'd like to do is if I could get a volunteer to come and try our Alexa quiz. So it takes about 4 minutes. I've reduced it to 10 questions because it does get quite tedious. And then once you've seen it in action, I can talk you through how it works. Have I got any willing receive pronunciation volunteers? Okay. Let's see if it works. I mean, it might not. You know demos. I did make a video of my daughter doing it, so we can just watch that if this goes wrong.
I've run my bricks, so I know what my score is, so let's see if it pans out.
Oh, yeah. Well, she'll only do the 10 questions, so
Okay.
it won't matter. Okay, so I haven't got an echo or a dot or anything, so I haven't got the voice activation. So I'll just launch it by pressing the button, and then she'll take you through.
You all have to leave the room because of GDPR. You know that.
I don't have an opinion on that.
Launch, analyze me.
Welcome to the Demon Allocator. This pseudo-scientific quiz will allocate you a technology demon based on your personality. To start, say start quiz.
Start quiz.
I'm going to ask you some questions to determine your Jungian personality type. Okay, now, do you prefer to make lists, or do you rely on memory?
Make lists.
All right then, would you answer the question the same way if I asked you again?
No.
Okay, now, are you skeptical, or do you want to believe?
I want to believe.
Interesting. Are you certain?
Yes.
Okay, now, how about time alone? Are you bored by time alone, or do you need time alone?
I need time alone.
Interesting. Would you answer the question the same way if I asked you again?
Yes.
Okay, now, do you accept things as they are, or are you unsatisfied with the way things are?
Unsatisfied.
All right then, would you always say that?
Yes.
Okay, now, do you keep a clean room, or do you just put stuff wherever?
My wife does it.
Interesting. Your answer.
Oh, can you repeat that?
Uh-huh. How confident are you in your answer?
Very confident.
Okay, now, do you think the term robotic is an insult, or do you strive to have a mechanical mind?
Strive to have a mechanical mind.
Thank you. Would you necessarily say that all the time?
Yes.
Okay, now, would you describe yourself as energetic or mellow?
Energetic.
Interesting. How confident are you in your answer?
Very confident.
Okay, now, would you rather sit a multiple choice test, or do you prefer essay answers?
Prefer the answers.
Interesting. How confident are you in your answer?
Very confident.
Okay, now, do you describe yourself as chaotic or organized?
Organised.
Uh-huh. Would you answer the same tomorrow?
Yes.
Okay, now, are you easily hurt, or are you more thick-skinned?
I'm easily hurt.
All right then, would you answer the question the same way if I asked you again?
No.
Thank you for taking the quiz. Your personality type is I, S, F, J. I guess from this that your strengths lie in DevOps.
Thank you very much.
I'm INTJ.
Oh, that wasn't far off. Yeah. So as you can see from that, I reduced the 32 questions down to 10, and it's still pretty tedious. So let's look at exactly how that worked. So there are 3 components to an Alexa skill. The first piece is the Alexa voice services. So that's the client API. You may have an Echo Dot at home, or I'm just using a Java client, which Amazon provide you. There's some open source code. Basically what it does is it packages up what it hears within a given time frame and sends it over to Amazon's servers, where the first piece of AI in this, where their voice to text runs. So there's a wake word, which the wake word logic is also combined that. So when you say Alexa, it doesn't have to be Alexa, you can change it to Computer or Echo or Amazon. And then that will start the timer for how long it records. It's very strict on how long it will record for. It's only something like a maximum of 20-30 seconds, so you can't use it as a listening device in the background. It's very strict on how long it will record. And then all the first piece does is send that up, and then as far as we know, all the Amazon piece does is turn it into a string of text. And then there's a second piece, which is known as the Alexa Skills Kit. And that receives the string of text. And I see it sort of as a sieve, where it will sieve the text that it's received, and it will filter out the bits that you're interested in. So this is a piece where you have to customize it yourself. The first bit is just there, you just use it. But this second piece, you customize for your own skill. So basically, you need to create a JSON file which represents the conversation structure that you're expecting. So they have these concepts that I'll drill down into a bit more of how we built it for this one, of slots and types. And then you have to define what you're expecting to hear. And then once you've captured out the bits you're interested in, these are sent via an API in JSON format to your server side. Now, you can have any server side you want, but the easiest one to use, because it's already lined up for you, you've already got the security set up, is an AWS Lambda function. So you then need to write yourself a Lambda function which deals with the information you captured and tells the voice service what to speak out in return. So I wrote a Lambda function for this one. I use JavaScript because I'm more familiar with it, but you can write Lambda functions in a number of other languages. And then this is the bit where you're in control of the code, so you can then call out APIs to hook in other logic that you want to bring in to your skill. And then underlying all of these three pieces, which is another good thing about using Amazon end-to-end, is whenever you build something for the Internet of Things, you've got to think about security first. You've got a device communicating across the Internet, sensitive information, and so you have to make sure that it's only going where you think it's going. And Amazon make this very easy. It's all via HTTPS using OAuth or basic authentication tokens. So it links to your Amazon account. So this skill is not public. I haven't published it. It's only currently available on my Amazon account. So when I log in and use a device, I can then call this skill. And then I grant permission for my Lambda function to receive the information and so on. So it's good that security is considered straight away. Right, so first we're going to drill down into that middle piece, the interaction model that you need to build. And the first thing you need to do is to define the types of answers that you want to receive. Now there are millions of built-in types for everything you can think of, like US first name is a type, city is a type, I can't remember what they call it now, but they have a type for queries. So you say, find out for me, or things like that are all classed as a query type. So Amazon have done a huge amount of work analysing not just the English language, it's available in other languages, I think only 3, but analysing the contents of all of our language and deciding how it might fit into types. But for this quiz, obviously, I needed specific answers for my specific questions, so I had to define a quiz answer type. And then I had to put every single possible answer that somebody might give to those questions into my quiz answer type. So, do you prefer to make lists or do you rely on memory? The key is they'll probably say either the words lists or memory. They might not, in which case it falls over. So, a lot of it is down to the person who develops this interaction model to make the skill work. And I think this isn't really a skill which is common in developers at the moment. Understanding the flow of conversation, English language, I don't think, this is necessarily skills that I have. So I think it will be interesting going forward, you know, as voice services become more and more widely used, we might get a whole different set of people come into the industry because they do have those skills, you know, analysing conversation and so on. So you might get psychology graduates, English graduates coming into development, which will be fantastic. So, yeah, so I've defined my quiz answer type. And then this, so those, Amazon calls them slots. So you define a slot, and that slot must have a type. And the slot is kind of in the sieve, it's the bits you want to catch. And so my slot here is my quiz answer. And now I have to tell Alexa how that quiz answer might arrive. It might just arrive on its own. You might just say lists, or you might say, oh, I'd probably prefer lists, or you might say, well, usually lists. So you have to spell out to Alexa which bits to listen for to catch that slot. So again, huge array of possible queries that you might make. So this is, for me, where the magic really fell out of Alexa. It's like, there's nothing clever here. It's just vast if statements, but that's quite common in technology, I guess. So I want to talk about this Amazon literal type. So as I mentioned, Amazon predefines hundreds of different types, but you can try and create your own. So if you think that, you know, it's not there and you just want to catch the thing that the person says and use it, there's this Amazon literal which should, in theory, just catch a piece of text. But it's incredibly difficult to use. So I tried to get one that would capture my name. So you have to put a default. You can see I've got Sarah and then the bar, and then the name is the name of my type. So when I ran this, and Alexa says, what's your name? If I replied Sarah, it would get it. If I replied, it's Emily, it would get it. But if I just replied Emily, because it didn't match the default or any of the sentence structures, it wouldn't catch that open text. So Alexa is really, really restrictive over how open you can make your conversations. You can't just capture what someone says. You couldn't use it for dictation or anything like that, because you really have to have the sentence completely defined, which, yeah, I thought was very interesting. Right, so one. Can you guys move this on from there? Oh, there we are. Right, so now looking at the third piece, the server-side piece. All of the transactions are over HTTPS. They're all stateless, but when you want a conversation flow, you need state. Alexa needs to know, are you answering the question or are you answering that assurance piece? And so states become variables which you then pass to and fro between the three pieces of Alexa. So for mine, I needed to define the start, you know, where you say start quiz in your beginning, and the quiz, which is when someone is providing the quiz answer, and then the assertion, which is when she says, you know, would you say the same thing tomorrow? So I've got my three states, and then, oh, I'm going too fast. And so this is my Node.js server-side code. So you can see it's just a bunch of handler functions, and each handler function picks up on a state. So up at the start there, you'll see that this is where you actually send the messages back to Alexa. So she'll speak the welcome message, and she'll then listen in case you go, I don't understand. And then she'll wait for the next state. So if you do say start quiz, then the quiz instant will be launched, and I'll set the state to quiz. So that way, when the response comes in, the quiz handler will be launched, and it will know to find the answer and store what you said. So that's basically how the states can be used across stateless protocols. Right, so the last bit. Whoop. So I just wanted to add in a bit more AI to this, because with the type scales, you needed a rating of 1 to 5, whereas what you're saying to Alexa is just answer A or answer B. So this is why I put in that second question, which makes it a really, really tedious quiz, but it's like, would you say that again, yes or no? So what I thought I'd do is I'll capture the response, and if you say the left-hand answer, you get a 1. If you say the right-hand answer, you get a 5. And then I'll say, are you sure? And then I'll run the response to that through a sentiment analysis. And if they say no, well, that's negative, so that will bring your score down, well, closer to the middle. And if you say yes, then you'll stay out on the edge. So I linked into this sentiment analysis REST API called theysay.io. And what that would do is give me a positive or negative response for the are you sure piece. It's text-based, so you know, if you shouted or use sarcasm, that's completely lost. But the whole of Alexa is, you know, you never get to capture any of that. I know with some of the other APIs, if you use Google, it will tell you what you said, but it will also give information on how it thinks you said it. But Alexa doesn't do any of that. Don't know how they say .io works. It's quite an interesting business model. They have a website, you send them a word, and you get back a number. I'm hoping it's a console in an old people's home, and they're there pressing their buttons. But it might be a neural network, you don't know. I tested it, though, and it's not very good. So if you say, I'm dead happy about that, it puts it as negative, because you said dead. But if you say, I'd be happier dead, then it says that's positive, because you put happy before then. So I think, yeah, probably if it is a neural network, it needs more training. But so this was the second piece of AI that we built into the flow, and it just shows, you know, how you can extend. Once you get to that Lambda function, you're free to call out and make your skill as interesting as you like. Oh, so the lessons learned that I had, voice interfaces are now obviously robust, ready for use. When we're thinking about how people deal with our systems, voice interfaces is just another interface. You know, they're ready for production. But when you use them is a different matter. I mean, I'm sure you found sitting the quiz pretty painful, and that was only 10 of the 32 questions. So it really has to be something short. You know, you have to think, you know, is it because you're busy typing and you want Alexa to do something else? Then you might want to look into voice interfaces. It has to be small input and output, particularly with Alexa, because you're limited by how much you can capture. But then, of course, you can look at the other voice services, because they're not all the same as Alexa at all. And then, as I've mentioned, the kind of skill sets needed for this kind of development, a language and culture specific to start with, and also imply an understanding of that language that maybe a lot of us sort of mathematician scientists don't have. So people who have that kind of ability to understand that you need closed questions. You want Alexa to ask you something that results in a yes or no, then she could be sure that she's got the right answer. Whereas if you have an open-ended question, you know, your JSON file defining the format is going to get out of control, and you're not going to be able to capture what you want. So you need these closed questions. And then, yeah, I use random quite a lot, I discovered, to give it a more realistic feel. So you might have like a list of responses that she makes, like, interesting, right. And then you'd use random to pick one of those, and it just makes it sound a bit more real. So that was interesting. Yeah, so it's an IoT device, just highlighting the golden rules of IoT. You're sending data over the internet, don't forget that. This is an internet-enabled device. You need to make sure that it's secured. And Alexa, I found, was a really good platform for doing this, because it helped you make sure that along the way you'd secured all of your pieces. Always have a manual override, I think, is an absolute golden rule of IoT. If anyone's got one of those lamps that can only be turned on and off with a remote control or with voice, then you soon discover that one. And then GDPR, I mean, you mentioned it. Voice is almost, we don't really think about how we need to control that data, but when you're capturing it and storing it through APIs, obviously GDPR is a massive issue. So just in conclusion then, yeah, people really enjoyed the quiz itself, the content. I don't think the voice interface was the right solution for it. We also had a web-based version, and people much preferred just quickly flicking through that. You can read so much faster than you can talk, and you can type so much faster than you can talk. So that was quite interesting. So as I've said, voice interfaces are just another interface now. You know, the piece that analyzes the MP4 of noise and turns it into text is amazing. Although those of you with different accents may disagree. Luis has offered to be my tester. And the way that the Alexa app was very limited in how you could build these skills. It wasn't anything like I imagined it would be. It wasn't open. It wasn't, you know, you couldn't just capture noise and do stuff with it. It really is very, very structured. So, yeah, I'm out of time, which is good, because that's the end. So, thank you for listening. And if you've got any questions, I don't know, come and find me after.